Alright, so in this video, what I wanted to cover is how you can iteratively build a generative AI system. Right, so this would be a two-part videos. So in the first part, we will talk about a few of the steps that you should take when you are building a generative AI system from scratch. Right, so let's get started. So first of all, like this video which I am creating, that is based on this blog post written by Chip Huyen. So all the credit goes to her, and I'm just improvising on the content that has been given in this blog post. I'm adding few of my observations on top of that, but most of the things are taken from this blog post. Right, so this is what the system, which we will see how we can build in a step-by-step manner, but the end product will look like this. Right, so this looks like a very complex system at the starting, but we will break it down. We will go in a step-by-step manner, and we will go through each of the steps, and then we will build this whole architecture in a step-by-step. Let's go through each of these steps. But first of all, like if you are building a generative AI, the simplest generative AI architecture will look like this. Once a user comes, the user will fire certain queries. Query will be sent to a model API for the generation phase, and the model API, using the user prompt or the query, it will generate the response. But we can improvise on top of this. We can add few of the things which will make this system more or less a complete system in a step-by-step manner. Right, now first let's go through what are the steps we will be adding on top of this basic architecture. Right, first of all, the step one is we will enhance the context. So we will talk about in detail each of the steps, but let's go through each of the steps at a glance at first. So then what we will do is we will put in guardrails to the system. That is step 2. And in the step 3, what we will do is we will add model router and the model gateways, which will make the system much more robust. And then slowly we will add the cache mechanism, which will reduce the latency. We will talk about several cache mechanisms which you can add into your systems, which can reduce the latency. And in the end, we will add more complex logic, and also we will talk about how we can also put in certain logics through which we can like write actions or take certain actions using your generative AI system. First, we will talk about the enhanced context. So this is a typical system where the user comes with a certain question. Now that question may not have the correct context to answer that question for the generative AI LLM model. So what the generative AI LLM model will do then is it will kind of generate an answer. That answer can be a hallucinated answer which may not be relevant to the user question. So this generally happens due to two reasons. One of them is like lack of the data that is actually required to answer this question was not there in the training data preparation step. So that data might be a proprietary data or very specific to a domain. So missing context can happen to the lack of the proprietary data or domain specific data in the training data that was used to train the LLM. The other one is the knowledge cutoff date. So that training data which I've talked about, that generally has a knowledge cutoff. Beyond that date, the whatever the happening that are going on in the world, that the model may not be aware. So in these two cases, the model will generate a hallucinated answer. So to tackle that, what we generally do is we implement a mechanism which we call as retrieval augmented generation. There we kind of bring in the domain specific data or the proprietary data as a plugin to the LLM system, and based on that the LLM will get the context, and then it will generate more relevant answer to the user question. Right, so you can see like we have certain domain specific data which can be then clubbed into the system by creating chunks. So the requirement to create chunks is mainly these documents can be very large in size. So if you want to put the single document into as a context to the LLM, that may be greater than the context length that is supported by the LLM. So what we do is we create chunks of those documents, and then we store those documents by creating the embeddings on top of each of the chunks. and we stored that in the vector store. And after that, what we do is we kind of retrieve the domain specific context from the vector DB, and then we kind of generate the relevant answer using that, right? So this is what we call as enhancing context. But by doing this enhancing context, we should be aware of few of the things. So let's talk about those things. So once the data, which is like a proprietary data or a domain specific data that has been loaded and chunked, then the retrieval comes into the picture, right? So this retrieval mechanism can be done using two main approaches. So one of them is like a term based retrieval. So this can be as simple as keyword search. For an example which was also given in the blog post, that if a user has given a query which contains the word transformer, so it will fetch all the documents that has this exact matching word of transformer. So it will pick up all the documents from the vector DB, and that will be retrieved, right? So generally we use the keyword based search like BM25 or the elastic search, which generally enable us to do this term based retrieval, right? So then there is option of embedding based retrieval. So that is also known as vector search. Here you kind of convert the chunks of data into embedding vectors using certain embedding models. Those embedding models can be open source model or a proprietary model like OpenAI. And then when given a query, that data, that question will be again converted to vectors, and then we will retrieve the documents using a similarity between the query embedding and the document embedding, right? So these are the very basic steps which you should be aware of when you are enhancing the context using proprietary data or domain specific data. Now, this vector search is a more expensive approach, which requires creation of the embeddings, then storing in the vector DB, and the term-based retrieval, which we talked about, that is a simpler approach, right? Now, what we can do is once we are talking about this vector search, there are certain algorithms which will be used to do this search in the vector DB, which is generally a nearest neighbor search, and few of the algorithms which are like approximate nearest neighbor, then FAISS, SS, or the Google's scan algorithm, or the HNSW lib algorithm. So these are the algorithms which are generally there, and these algorithms are also has certain benchmark through which they have been like ranked, and based on your use case you can like pick any of these algorithms, right? The matrices are like recall, so that kind of tells you like what fraction of the nearest neighbors found by that particular algorithm, right? So then there is a query per second, which is nothing but QPS. So that is nothing but like number of queries the algorithm can handle per second. So this is actually very crucial when we are building a high traffic applications where a lot of questions or a lot of prompts are coming into the system. So the queries per token becomes a crucial metric when you are designing your generative AI application, right? So then we have the build time. So this build time is crucial when you have very frequent updates to the vector database, or where you are storing the embeddings of the documents, right? So this will tell you like the time required to build the index, right? So this metric is very important if you are frequently updating your index or the vector DB. And so then metrics is this index size, which will tell you the size of the index created by the algorithm, and this is actually a crucial metric when we are assessing the scalability of the algorithm, and also the storage requirements also coming into the picture. So that time, what is the index size that you need while building the system, that you should take in consideration while enhancing the context using this retrieval mechanism, right? So then what we generally do in case of production system is we try to combine several architectures or several algorithms, and then we go for the hybrid approach, right? So there what we do is we do a step-by-step approach or a sequential pattern we try to follow. So first of all, like a cheap, less precise retriever such as a term-based system fetches the candidates. So if I give you an example, as I mentioned, like transformer, is one of the keyword that was present in the user query. So this, at first step, what it will do is it will pick up all the documents without understanding the context. It will pick up all the document that has transformer, right? Now there is the second step. What we will do is we will do a more precise but more expensive mechanism such as k nearest neighbors, and that will find the best out of those retrieved context, right? So if I again give you the example of transformer, right? So that transformer can be a movie, that transformer can be electrical system, or that transformer can be based on the attention mechanism also, right? So second approach is which is a much more expensive, that will understand the context of the transformer, and then if the question is related to the attention mechanism, then it will only fetch the relevant documents where the attention mechanism based transformer architecture is mentioned, right? So this is like a two-step approach we generally follow. And then what we can also do is, to improve the performance of the generation phase, is we can also add a re-ranking, right? So this is just to avoid the concept which is nothing but lost in the middle. So generally the LLMs, which given a context, it will try to generate the answer looking at the first portion of the context, right? And the portion which is belonging to the middle part of the context, or the end part of the context, that might not be given much more importance as compared to the first part of the context, right? So that's why a re-ranker will fetch the documents, and it will give higher importance to the much more relevant documents, and that will be placed at the starting of the context, right? So which can also avoid this lost in the middle concept. Then the other pattern is like an ensemble approach, where you can use different retrieval mechanisms and then take a majority voting or an ensemble approach to combine the results using different retrievers, right? So this is what we can do using using a hybrid approach or a step-by-step approach to build a better context for the LLM to generate the answer, right? So then what we can also do is, maybe certain questions are not present in the vector DB, that are present in the a SQL database, right? So based on the query, your system might need to route the questions to particular section of your system architecture, and that can be dealt with by adding agentic RAG, right? So based on the query, it will route the question to either vector DB or to the text to web, text to SQL database, or it will do a web search. So that will be taken care by a agentic approach. So you can also bring in this flavor, which is agentic RAG, to fetch the better context, right? Now sometimes you will see that the better context is not getting fetched from this vector DB or the text to SQL conversation process, right? So maybe the user question is not a very elaborative one. So that time what we need to do is we will rewrite the query based on the given question, and that rewrite of the query, the newly generated query will fetch better documents using this query rewrite option, right? So that you can also think of adding to your system design component, and that can retrieve better context from the vector DB or from the SQL database or from the web search, right? So now using this enhanced context, the architecture looks like this. So the query will go to this context construction phase, where you can have a RAG or an agent or a query rewriting phase, and based on that it will either go to a vector search or run a SQL query, or it can do a web search to get the context, or it can also go to certain databases to bring in the historical chat or the tables or the documents that is required to answer that question. So this is like a first level of enhancement we can do, where we are bringing in the context using certain external database, right? So then we can go back to the model API, where we will pass the context to generate the answer, and that response will be sent back to the user. Okay, now let's move to the step 2. So in the step 2, what we will do is we will put in guardrails into our system. So this guardrails generally help us to reduce the AI risk and protect not only your end users, but also us who are the developers, right? So they should be placed whenever there is a potential risk of failures, right? So guardrails will kind of input system to tackle those failure points. So let's discuss what are the types of guardrails. So we have generally two types of guardrail. One of them is like input guardrails and output guardrails. So let's first talk about what is input guardrails. Now, input guardrails also can be categorized in two scenarios. So one of them is like when the users are trying to leak private information to the external APIs, and the other category is the model jailbreaking. So in terms of leaking private information, this generally happens when users of your system are writing a prompt, and there is a risk that they are exposing your private information to the external model APIs. So that from writing some sensitive data into the prompt itself, they might expose those information to the external APIs, right? So that is one of the criteria of failure point whenever we are writing sensitive information in the prompt. Right, so this what you can do is you can use many of the available tools to automatically detect sensitive data which can be present in the input prompt, right? So those sensitive informations can be like your personal informations which are related to ID numbers, phone numbers, or bank accounts, or human faces, or specific keywords or phrases which are associated with companies' intellectual properties or privileged information, right? So one of the example which you can see where user is trying to debug certain issue. So what the user has written that I got 403 errors on this code. So what did I do wrong, right? So that is the question, but along with the question, the users has exposed the token that should not be exposed as part of the input prompt, and also the URL that is been mentioned here, right? So you can see like the users are not much aware how they should structure their prompt, so that's why they are exposing private token in the prompt itself, and that can be very dangerous if you are writing the prompts in such a way, right? So you can put in some mechanism through which you can detect uh, this leakage, and you can like replace this token to some masking thing, and then you pass that prompt to the external APIs, right? So masking is required whenever there is a sensitive information that is present in the prompt itself, right? So the second one is the model jailbreaking. So in this model jailbreaking, you can ask AI models to say or do bad things. So a lot of people are trying out in the open internet, like they are trying to do some funny things with the model, and they are changing the model behavior with that. But that is fine for the experimentation and the funny part. But whenever you are building a production grade app, so there this can be very dangerous, right? This is specifically dangerous when your system has access to tools, right? So imagine a query or a prompt which has access to the SQL tool, and using that tool, users are writing certain prompts which can like execute certain queries which can corrupt your data that resides in a particular SQL database. So that is very dangerous. So that can be detected at an early stage, and then the further mitigation step will be should be taken, right? So then what we can also face a scenario where we are asking models or systems to make outrageous statements, right? So which it should not be making, right? So you can again put in certain mechanism through which you can detect the out of scope topics for your application. So in that way you can like classify the intent of the prompt, and based on that you can say that this is out of scope topic, so please refine your questions or prompt, right? So in that, so as I mentioned, like you can use any of the simple algorithms or sophisticated algorithms to classify whether an input is on a predefined restricted outputs or not, right? So based on that you can like put in certain input guardrails so that there is a lesser chance of exposing sensitive data to the external APIs, right? So then let's talk about the output guardrails. So generally whatever the LLMs we are using, they are probabilistic in nature. so their outputs are not reliable, right? So you might have seen that you are using the same prompt and you're getting, if you run it multiple times, you are getting different outputs at the different times, right? So that is because of the probabilistic nature of the LLMs, right? So you can put in guardrails to significantly improve your application's output quality or reliability. So this that can be enabled by putting in output guardrails, right? So output guardrails is also, there are two types where you need to catch and you need to measure the quality of your output response, and based on that you can like put in certain failure management techniques through which you can mitigate those issues, right? So let's first talk about the output quality measurement. So you can like catch the outputs which fail to meet certain output standards, and based on that you can identify the failure points in your system, right? So that failure point can be either an empty response from the model, or it can be a malformatted response. Like if you are asking model to generate a JSON output, and while generating the JSON output, model has missed certain formatting or it has missed certain brackets, so those will cause the malformatted responses, right? And also the model can generate toxic responses, so that is also a failure point we should catch. So then also your model can generate factually incorrect responses where the model is kind of hallucinating and making up the answers to give uh, wrong answer where it does not have the correct context, right? So you can use certain hallucination detection tools which can detect the hallucination in the output, and based on that the further mitigation step will be taken, right? So response can also contain sensitive informations, so those sensitive information can be part of the training data. So as it was part of the training data, when you are asking a question related to that data, your response will also will have those sensitive informations, right? So other thing can be like your sensitive information is also present in your vector db. So whenever the context is retrieved, that sensitive data also got retrieved, and that is coming as a output or a response to the user prompt or question, right? Then also we should be aware of the brand risk related responses. So if you are building a chatbot which is related to a specific brand, so you should make sure that whenever the output is generated, that is not harming the brand quality or the brand risk, right? So you can put in certain sentiment detection algorithms which can detect the output and which can ensure that the only the right sentiment is returned from the model response, right? And also some bad responses in terms of quality can also be generated from the output. So what you can do is you can put another LLM to detect those output quality. So you can use another LLM as a judge to measure the output quality of the generated response from your system, right? So once you are aware that these are the scenarios where my model is making mistakes, or it is not according to the standards of my predefined standard quality, then what you can do is you can put in certain failure management to tackle those, right? So as I mentioned, like these models are probabilistic in nature, so most of the times if you rerun the query, so because of this probabilistic nature, it will like do the corrections in the output and you will get better responses. So if you are getting a empty response, then if you again retry, it might generate the response at the next time, right? So this in that way you can mitigate those issues with a retry logic, right? So but this increases the cost and latency because you are making multiple calls based on the failure. So the cost is a issue, but if you want to mitigate these issues, you should put in mechanism where you have a retry mechanism, right? So to mitigate the latency, what you can do is you can make two parallel calls based on the user prompt, and then select the best response out of those two generated responses, and that can be returned as a response to the user, right? So this can reduce the latency, but yeah, that will increase the cost, but that we should be aware of, and that we are ready to take in that extra cost in terms of generating high quality responses, right? So also you can put in certain fallback mechanisms where you are falling back to the human, right? So you have certain mechanisms through which you are detecting that the users are getting agitated while doing the conversations with the chatbot. So when you detect those type of agitations in terms of user response, you can like straight away route those questions to the human for tackling those questions, right? Or those conversation. Or if the users are making complex queries, you can again like route those queries to the human to answer those questions, which can give better responses to the human, right? So these are a few of the techniques which you can put in along with the input guardrails. Along with the input guardrail, you can also put in output guardrails to manage this failure points, right? So now this comes with few of the trade-offs. So one of them is like a reliability and the latency trade-off, which we already talked about. Like you can make two parallel calls to reduce the latency, but that will reduce the latency, but that will again like put the cost high, but that is fine. But that is will increase the reliability of your system by making more sensible responses and eliminating the false formatted response or the empty responses, right? Then also there is a trade-off between the self-hosted model and the third-party APIs. So if you are using a self-hosted models, then your data is not going outside your organization, but again like the self-hosted models may not be as good as the third-party hosted applications. So in that way, you need to take a measured approach through which you decide whether you want to go for a self-hosted models or a third-party applications where you can like send your data to the outside world, right? So with this trade-off, now you can think of like whether you should put in the guardrails, and to which extent you want to put in the guardrails, that you can decide. And now your system architecture will look like this, where the query comes from the user, then it goes through a query context construction phase, and then you put in the input guardrails where you reduce the PI related informations, which can be a sensitive information that can be exposed to the outside world, that you can reduce using input guardrails. And also once the model generates the response, then you can put in certain scoring mechanism through which you detect the quality of the response, whether they are meeting certain standards or not. And then you can put in certain output guardrails which are related to, which will ensure that the structured output is generated, or there are no empty responses, or quality of the response is up to the mark, right? So we are slowly making our system complex with each of these steps. So in the next video we will talk about the other three steps that you can put in to make your system much more robust and much more reliable in terms of generating the response from the model, right? So thank you, see you in the next video.